Hi guys, we have a couple of more questions from section 4.5. The first one is number 30. So this is actually very similar to the last video that I made on problem 29 and 31. It's very similar, except something actually happens very nice about this one, that you may not even have to approach it the same way as we did 29 and 31. Okay, but let me work it out for you. So we have 5 times 1.2 raised to the 3x minus 2 plus 1 equals to 7. Okay, so if you remember last time, in the last video, we told you to solve these types of, which are called exponential equation. You have to make sure the exponential expression, which is 1.2 raised to 3x minus 2 is by itself on one side, and then a number on that side, right? So first we're going to have to remove the 1 and 5, and then we can approach it by taking the log of both sides. Okay, so right now we're just going to subtract 1 from both sides to remove the 1 from the left. So this becomes 5 times 1.2 raised to the 3x minus 2, and that's equal to 6. Now this is where something special happens. When you divide both sides by 5, of course, you get rid of the 5. In this case, you notice that on the left-hand side, of course, you still have the same thing, 1.2 raised to 3x minus 2. But then 6 divided by 5 also happened to reduce or become 1.2. Now, this doesn't always happen. I'm sure in our problem 29 and 31, this didn't happen. That's why we had to take natural log of both sides to bring the exponent down. You can still do that here, by the way. Except here, if you notice, you do have the same base. And, of course, any number means to the first power. 1.2, same thing as 1.2 raised to the first power. And if you remember in section 4.2, we had these exponential equation where you have the same base. And the rule says you can drop the bases, that the exponents equal to each other. So in this special case, you can actually use that instead of taking natural log of both sides, which is what I did in 29 and 31. And that still works. But this observation, of course, makes your life a little bit easier. Now we're just going to solve for x. So we're going to add 2 to both sides. And, of course, 1 plus 2 is 3. And then finally divide by 3. And so, of course, you get x equals to 1. Okay? So there is your solution for this exponential equation. Again, at this stage, we could take the natural log of both sides like I did in 29 and 31, but because we were very fortunate to have the same base, so we just dropped the bases, set the exponents equal to each other, which was a rule we learned in section 4.2, okay? All right, let me do one more. I think the student wants to see also number 43. Now for 43, which is similar to other problem that I did from this section in the same video, or the next video that I did after 29 and 31. So if you remember, we end up using this rule that says log base a of x equals to y is the same thing or equivalent to saying x equals to a to the y. Okay, so this is the one we call logarithmic equation. This is the exponential equation. So we're going to use this idea to help us to solve it. So our problem number 43 says natural log of 4x equals to 1.5. Okay? Now, as you know, natural log, as we learned in section 4.4, natural log actually is a short name or nickname for log base e. In this case, you might want to write its long name so you can make your transition easier from logarithmic to exponential. Excuse me. So now here we have our logarithmic equation. We're just going to change it to exponential. That says 4x must be equals to base, which is e, raised to 1.5. And of course, to solve for x, we're going to divide by 4. And since they want the answer in the exact form, that's pretty much it. There's your x. 4 cancels. E to the 1.5 divided by 4. Okay, so there is your final answer for this one. Now, again, you could approximate that with your calculators. Don't forget, you do have an e to the x button, but in this case, they want the exact form. So the exact form would be just e to the 1.5 divided by 4, okay? I hope that helps.